Okay, so question 48, using any alkene and any other reagents, how would you prepare the following? So there are 6 sub-questions here. I'm just going to do 3 just like before, and hopefully this will help you figure out or get you started. So sub-question B, we have chlorine alkane or chlorinated alkane. So a couple things you should think about whenever you see this problem is that we only have a couple of ways of, forming a halogenated alkane, and all of them stem from alkenes. So the first thing you should think of when you see this, is that you should think alkene. Okay, so going backwards, we're going to use retrosynthetic arrows. So if we haven't talked about retrosynthetic arrows yet, we will very, very soon. But again, these retrosynthetic arrows indicate that on the left we have products, and on the right we're going to draw reagents. So this is the product right here, and on the right will be all of our reagents. So we're going to start off with an alkene, and there are 2 different alkenes that we could potentially use. We could have an alkene right here, or we could have an alkene on this single bond right here. So let's go ahead and draw both possibilities and see if one might be better than the other. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we can either have our alkene right here, or we could have our alkene right here on the end, like this. Okay, so now the only way that we know of to add just a chlorine or just any halogen, we are going to want to add some kind of acidic halogenic acid. So in this case, we're going to use HCl, and um, okay, so we're going to end up using HCl here. So starting with either one of these alkenes, let's go through them and see if we can find if they'll give us the product. So if we add HCl to this starting material, let's call this starting material A and this starting material B, what we'll get are 2 potential carbocations. We'll either get this carbocation on the left, 1, 2, 3, 4, 5, right here where the positive charge is on this carbon, or we'll get this carbocation on the right, 1, 2, 3, 4, 5, right here. Okay, so that's one possibility. In this case, we'll get 2 totally different products. This guy on the right is going to be the one that'll give us our actual product. Okay, because remember we have chlorine on the 2 positions, so 1 from the end. So at this point, whenever we're drawing these 2 intermediates, we have a chlorine minus in solution that needs to act as a nucleophile. So this guy can either attack here, where it'll actually give us an attack at the 2 position, or an attachment point at the 2 position. Or if we use it here, if we have a chlorine attacking here, we're going to end up forming a chlorine carbon bond on the 3 position. Okay, and that's definitely not what we want. So we don't want this guy. We do want this guy. Okay, so the question then is, it definitely looks like this alkene will give us the product, but is it any different from using compound B? So let's go through that real quick. So if we used compound B, we're definitely going to get 2 different intermediates. We're going to get one intermediate where we have the positive charge on carbon 2, or we could also get an intermediate where we get the positive charge on carbon 1. Thinking about carbocation stability, this carbocation is secondary, this one is secondary, this one is secondary, and this one is primary. Okay, so of these 2, for compound B, the secondary carbocation is going to preferentially form while the primary will not. So the primary carbocation right here is not going to form. Okay, so will not form. So it's going to be right out. So it's not even going to be possible to have that attachment point. So we're going to make all of our attachment points at this carbon to chlorine bond. So this carbon 2 to chlorine. So in this case, this will end up giving us our final product. But this one will also give us our final product. The difference here is that if we used alkene A, there is no difference in stability. So we have an equal probability of forming this carbocation on carbon 3 as the carbocation on carbon 2. So if we actually used, alkene A, what we'll get is a 50-50 mix. We'll get 50% chlorination on 2, and we'll get 50% chlorination on 3, which is not what we want. So in this case, we'll get 100% chlorination on 2. And so of the two, they'll both end up working, although alkene B is going to be the better choice. So this is the better choice for what to use. We'll get more of the actual product that we want, and this is the worst choice because it'll give us the product, but just not in as good of a yield. Okay, so if you drew this alkene on an exam, you would be correct, but you would not be as correct as the person who used this alkene. So this person would get 100% credit, and you might only get 50% credit if you use this guy. Okay, so there's subtleties to this. Okay, so this sub-question C, what we're going to form is our alcohol, and again, we only know how to form alcohols so far from alkenes. So we're going to start off with an alkene. I'm going to take this guy and I'm going to pull him down a little bit just to make it easier to work with. Okay, so at this point we only know how to do or to form alcohols from alkenes, and we can either form an alcohol in a Markovnikov fashion or an anti-Markovnikov fashion. So let's go ahead and draw our retrosynthetic arrow and try to figure out what the starting material might be. Okay. So we know we're going to start from an alkene, and we know that we're going to have to put the alkene at least alpha to this hydroxyl group. So this might be the alpha position. So we're going to have an alkene right here. Okay, so notice that this is a carbon. This is not a carbon. A lot of mistakes come with students not just reforming the alkene, but trying to add on an extra bond right here. So what this would tell me is that you have a carbon here and here instead of just one extra carbon. Okay, so this is right out. You can't do this. And so now this is the only possible alkene we could possibly use to form our alcohol. So you have to remember what reagent will give you Markovnikov, what reagent will give you anti-Markovnikov. So since we want to put our alcohol here, this is going to end up being an anti-Markovnikov reaction. So the anti-Markovnikov reagents are going to be the hydroboration oxidation. So what we want to do is use BH3, step 1, step 2, H2O2, and OH minus. If you want to add THF as the solvent, that's totally fine, but you don't necessarily have to do that. Okay? Okay, so sub-question D, we are forming a halohydrin. So just like with the last question that we did, we're going to end up forming our halohydrin from alkenes. So we're going to end up doing a retrosynthetic analysis right here. I'm going to draw our retrosynthesis arrow. And you know that the alkene is going to come between the hydroxyl group and the halogen. So we're going to end up putting our alkene right here in between the two. So if we number our carbons 1, 2, 3, 4, 5, 6, this is going to be 1, 2, 3, 4. So we want our alkene to be between the positions where we have our alcohol and our bromine. And now all you have to remember is what the reagents are. So the reagents are going to be Br2. But instead of just doing this kind of addition with Br2 and an aprotic solvent like methylene chloride, dichloromethane, this wouldn't work. This would not give you the halohydrin. So we're not going to do that. So instead, the solvent that we're going to use is going to be water. So because we're using Br2 and water, we're going to end up taking the alkene, reacting it with Br2 and water, and we're going to get our halohydrin. So again, this is going to be the product. This is going to be the starting material. And this is going to be the reagent. Well, technically, both of these. These are both reagents. Okay? Alright, so try to do the other three on your own, and we'll move on to the next question.